In this little video clip, what I want to focus on is question 8 from the November 2017 IEB paper 2. What this question deals with is a topic referred to as dynamic geometry, which involves things like moving points, folding, drawing lines on a diagram, or in fact using given information to create your own diagrams. This is a brand new trend at the level 4 level in the paper 2 questions, and it incorporates algebra, trig, geometry, and Euclidean and analytical in the thing. So let's have a look at the questions. What it did, it said it gave them a circle. So let's just go here and draw this down. You were given a circle there. Okay, here it is. And it's got a center, 031, an angle A at 30 degrees. Notice there's a Cartesian number plane. And of course, they had a little point C there, which cuts the y-axis at -2. And then they've got a variable point B, which is over here. So let's just mark that in quickly. There it is. Okay, so this is O and that's B. Okay, now the first question was quite simple. It said there, determine the length of OC. Now, O is the point 31 and C is the point 0, -2. So you just simply use the distance formula for 2 marks there. Pretty easy. All you do is say, well, the length of OC is equal to, okay, it's 1 minus -2. Okay, so it's 1, so it's the x value, should I say. Let's go 3 minus 0 all squared plus 1 minus -2 all squared. Okay, so that's pretty easy. So OC squared is 9 plus 9, which of course is 18. And then OC would be the square root of 18, which is 3 root 2 units there. Okay, so we know that the radius, in other words, this is actually the radius of the circle would be 3 root 2. This is 3 root 2. And there we've got it there. Okay, so that's the length of OC. So let's look at the next question now. Okay, now here's where moving points comes into this dynamic geometry. B moves along the circle until BC is parallel to the x-axis. Write down the new coordinates of B. So I'm going to bring up GeoGebra here, and let's have a look. So let me get a little thing here. There's your point B. And what's going to happen is that if you look at this point B, it's going to move along the circle such that, if you think about it carefully, as such that it moves so that it goes, so that the line segment there goes parallel to the x-axis there. So if we have a look at that, what we've got is the point B, 6, -2 there. And in fact, it's quite easy that length C to B would be 6 units. The coordinates would be 6, -2. So let's do that again. Watch the dynamic geometry. That's where we were. It moves. It's going up there in an anti-clockwise direction till it runs, the segment runs parallel to the x-axis. And there it is. You can clearly see it's 6 and -2. So you can see how that works. Remember, with dynamic geometry, you can move the point all over. That's why it's so critical to teach with these technologies in the classroom, especially for geometry. And this is the new trend in the IEB, these kind of moving points. Okay, so the question is, we've got the coordinates of B. Very easy to do. Okay, so let's have a look. We'll go back to this diagram. There is B, and the new coordinates would be 6, -2. That was the original B in its position there, and we can call that B image if you like. You can do that. You can use another letter if you like. There's O, the center there, and we know that the radius is 3 root 2, 3 root 2 there. Okay, now the next question says, if you look at this, calculate the size of CAB for the new position of B. Of CAB for the new position of B. So that means that we have to introduce a little line. C, there is A, and we want to get it down to B there. Okay, so let's introduce another little line. Okay, so there's the line, and we've got to get the new CAB. So what we're looking at is this angle here. Let's get another red pen. Let's go here. We're looking at the angle C, A, and B prime. This is the angle we're looking for there. Okay. Now, that's quite difficult to do, but if you go down to the bottom triangle here, remember that this line CB image is parallel to the x-axis. So what we want to do is if we can find this angle, which is actually double that angle. Now, in this triangle COB image, you of course can easily work that out using the cosine rule. So let's do that quickly. We'll use the cos rule to then get the angle COB, and then hence get the angle CAB. And here it is. Okay, so cos rule, let's look at that. So we know that if we have a look, this length here is 6. I'm just going to write it in quickly here. There it goes. This length is 6 there. That's 6. We've got the radii of the circle, and we can easily use with the 3 sides, we can easily get that angle COB image. So let's write down using the cos rule what it looks like. So we know that if we think about it carefully, that we know that OC is equal to OB, and the reason for that is going to be equal radii. So that's the first important thing that we need to do. Okay, and we know that from the cos rule, 6 squared is equal to, let's just go back up there, look at this carefully, 6 squared is equal to, now you work with the 3 root 2's, is going to be equal to, and there it is. Okay, and you simply use the cos rule, and then we're going to work out what that angle is. So if we go through this whole process, what we're going to get is this, and there it is. So if we go through this, we see that using trigonometry, that COB is 90 degrees, which of course makes quite a lot of sense. So this COB is 90 degrees over there, which of course means if that's 90 degrees there, then because of the angle at the center is twice the angle at the circle, that angle that we want is going to be 45. So we can say, therefore, the angle that we do want, COB, is half of that. There we go. And that's angle at the center is equal to, and there it is. Okay, guys, let's have a look at number B quickly. It says B moves from its original position along the circle in an anti-clockwise direction until the area of the triangle OBC is 9 over 2 square units. Find the shortest distance that B has to move along the circle for the above to occur. Okay, so let's just bring this down and see what they're saying. Well, if you look at the original triangle, so let's get that quickly. We're going to get the original triangle. That's O, that's C, and that's B in its original form. And we can talk about the area of this triangle. Now, what they're saying is that this B must move up the circle in an anti-clockwise direction, so that the area of triangle COB will be 9 over 2 square units. Okay, now as you know from calculus, is that and from moving triangles around, that the area can change. Okay, so let's go to GeoGebra and see what is actually happening. But before we do that, let's just quickly do something with area. We know that the area, if you think about it, the area of triangle OBC, let's just have a look at that. The area of triangle OCB is equal to a half, and then we've got the radii here, 3 root 2, 3 root 2, and then this little angle is the included one, so it's a half, 3 root 2 multiplied by, again, it's 3 root 2, let's just move that across. There it is there. So we've got 3 root 2, and off we go. So there's another 3 root 2, and we've got the sine of that angle COB there. Okay, so let's bring that across. And here we go, COB. Okay, so that's pretty cool. Okay, now we know that the area is 9 over 2. We want it to be, this mess here goes 3 times 3 is 9, root 2 times 2, so it comes to 9. Sine COB, and then we've got, well, a half is equal to sine COB there. Well, if you times both sides by 1 over 9, and then you get the angle COB would be 30 degrees. But remember, with trig equations, if sine is positive in the first quadrant, it's 30, but in the second quadrant, COB could also be 180 minus that. So there's two possibilities, an obtuse angle triangle and an acute angle triangle. So let's go to GeoGebra and check it out how this works. Okay, so if we look at this, I'm just going to bring that down there. Okay, that's the original triangle with an area of 7,8. Okay, and if you remember that angle there is almost 60, if I'm just a bit more accurate here. Okay, so there it is. It's there's the original area, about 60, 70. Now, if you move this, watch this, that'll give you about 30 degrees there, with an area of 4,5. Okay, that should be about, if we just make it 30 there, let's see, there it is, about 30. So that's where 4,5 is. Now, if you go all the way up in an anti-clockwise direction, look at the area, you're getting 4,5, as well, and then the area is going to be 150 there. And bear in mind that this angle originally there is 60 degrees. From the angle at center is twice the angle at the circumference there, you see. Okay, so that was the one. Okay, so let's go back to the OneNote. All right, so now what do we know? Okay, here we go. Okay, so we don't want that area because, simply because what's going to happen now is that you would have had to go in a clockwise direction to get that distance moved. But what we actually want to do is go in this direction. So how it works is that you start off with B, and then it goes in an anti-clockwise direction in that direction there, okay? And we want to get the length of this circumference here, the shortest distance moved from there to there. Let's call it D. Now, what we know is that this angle is 150 degrees. We already know that that piece is 60, so what do you know about that? It's 90. 150 minus the 60 is 90, and that means that that's a quarter of the circle. So when you talk of moving along a circle, you're talking of circumference, which of course is 2 pi r, the formula. But of course that piece D is actually 1/4 multiplied by 2 pi times the radius, which is 3 root 2, and that, if you work out, is 6,66 units, and there it is. So you can see, guys, a lovely question that involves a whole lot of mathematics there. Please make sure that you master these questions. They are going to come up again and again in the IEB exams in the future. Level 4 questions. Enjoy them.